Alright, so before we can continue to expand the work-energy theorem, we need to discuss the difference between conservative forces and non-conservative forces. So conservative forces are going to lead to a conservation of mechanical energy, and non-conservative forces are going to lead to a loss or a gain of energy into the system. So that's the difference between conservative and non-conservative. The other difference between the two is going to be whether the path matters. So the path over which the force is applied does not matter for conservative forces, but it does matter for non-conservative forces. So let's talk about the force due to gravity versus the force due to friction. So imagine that I am moving my eraser on the whiteboard on the wall along this path. So as I push it up, the force due to gravity is going to try to pull it down in the negative y direction, but delta y is increasing. However, as I go from the left to the right, the force due to gravity in the x is actually 0. So there's actually no work done as I move it in the x direction. So work here equals 0. Then as I move it back down, the force is still in the negative y direction. However, now my delta y is going to turn out to be negative because I'm going from a higher position to a lower position. Then once I go to the left, so in the x direction, once again the x component of the force due to gravity is 0. So there's also no work done on this leg. So this path and this path, so in the y direction, notice that one of them is negative, so this would give me negative work, and this would give me positive work. So the work net the whole way around this path is actually 0, which is a way of showing that it is path independent. So if you go around a closed loop, you should get your work net to be 0. So we know this is path independent. Now in contrast, if we look about the friction that the eraser would experience as it's going around that square path, on the way up, since the friction is going to resist me being able to push the eraser up the board, since I'm going in a positive y direction here, the friction is going to oppose in the negative y direction, but delta y is going to be positive since I'm moving up. When we go from left to right, since I'm moving in a positive x direction, friction is going to be negative, and delta x is going to be positive. When I go down, the force due to friction is going to be positive because I'm pushing in the negative y, so friction is going to resist in the positive y. But since I'm going down, delta y is going to be negative. And as I go from right to left, friction is going to end up being positive because I'm moving in the negative x direction, and then delta x here is going to be negative. So if you focus in here, this work is negative, this work is also negative, so they don't cancel each other out. This work is negative, this work is negative, so they don't cancel each other out. So here you get an actual work value if you had numbers to plug in here. So that tells me that while the force due to gravity was a conservative force, the force due to friction is a non-conservative force. So in the remainder of this topic, I'm going to introduce you to two conservative forces that are going to do work on our objects. The first one you already know about, the force due to gravity. And I'm going to show you how to incorporate non-conservative forces into the problems. So how do we deal with the fact that we may gain or lose energy based upon non-conservative forces like friction or air resistance?